Morning once again, algebra students. So today we're going to be talking about lesson 7.6, which is rational exponents. In simple terms, rational means fraction, exponent is the power. So we're talking about what do we do when the power is a fraction. Our main definition is going to be that b to the 1 over n power is the same as the nth root of b. So this bottom number, which we talked about earlier, is the root of that. It's important to realize that when the b is negative and the n is even, when the root is even, there's no real root because you cannot take the even root of a negative number. So in anything that is in exponential form, so when we have a power that is a fraction, we can write this in radical form. When we say radical, we mean what you're familiar with as the square root sign. It's actually called the radical sign. So a to the 1/5 we could write as the 5th root of a to the 1st, but we really don't need to put that 1 there. D to the 7/4, that would be in radical form, the 4th root of d to the 7th power. And then likewise, we can go from radical form to exponential form. This is like c to the 1st. So this could be written as c to the 1/8 power, power over root. This one here would be c to the -5/3. And if you remember, as far as our negative exponent rule, we would need to put that in the bottom and make that exponent positive. So you should be able to go from radical form to exponential form, and vice versa. Now, simplifying expressions with rational exponents. So now we're going to use that table of powers that's up on the board, and table of perfect roots and so on. And if we use our property we just learned, 8 to the 2/3 power is the same as the cube root of 8 squared. Now looking at the board, the cube root of 8, that's a perfect cube, that is 2. And then 2 squared would give you 4. So 8 to the 2/3 power is 4. 16 to the 3/4 power, we'd have the 4th root of 16 to the 3rd power. And again, we should do the root first because that'll make it smaller. The 4th root of 16, looking at that x to the 4th column up there, would be 2. So this would be 2 to the 3rd, which would be 8. 25 to the 3/2 power. That is the square root. Don't really need the 2 there. It's just assumed to be there. Cubed. And the square root of 25 is 5. 5 to the 3rd power is 125. 5 times 5 times 5. 64 to the 2/3 power, that's going to be the cube root of 64, which is 4. And then we're going to square that, which gives me 16. 4 to the 5/2 would be the square root of 4, which is 2, to the 5th power, which would be 32. Again, always using that list of perfect powers and perfect roots that are up on the board for you to use, recognize, and get very familiar with. 27 to the 4/3 power would be the cube root of 27, which is 3, and then 3 to the 4th power. 3 times 3 times 3 times 3 would be 81. Now we're also going to be dealing with, if you have properties that are other properties that we've learned are also going to be true with rational exponents. So remember we learned about the negative exponent property, which means we move it to the bottom and we make it positive. We learned that if you multiply two numbers together with the same base, you add these powers, so that's x to the 7th. We learned that if you divide two numbers with the same base, you keep the base and you subtract. And when we have the power of a power, we multiply those together. So we just have to do the same thing with fractions. So for example, the 4 to the negative 2/3 would be the same as 1/4 to the positive 2/3. 1 to any power is 1. And then I've got 4 to the 2/3 on the bottom, which we just learned. This is the cube root of 4, which we cannot do. That's not a perfect cube, so therefore we would not be able to do anything more to that, and we would just leave it like this. Here we've multiplying two numbers the same base. You're going to keep that base. You're going to add these. When we're adding fractions, you need a common denominator, which we already have. So that'd be 6/3, which could be reduced to 2, and that would be x squared. Here we got a power of power. So you're multiplying those powers. How do you do that? Straight across. Top, top, bottom, bottom. So it'd be x to the 2/6, which reduces to 1/3, which we know is the same as the cube root of x. And then we're dividing two numbers that have the same base. We're going to keep that base. We're going to subtract these powers. Same denominator, good. So it'd be 3/3, which would be the same as x to the 1st, which is plain old x. So this should help you, again, in completing your practice. Make sure you're continually looking back through the video, slowing it down, looking at different examples to help you in doing the assignments.